All right, here's a rather challenging integral. Integration from negative pi to pi of 4 cosine 3x, 3 sine x plus 4x plus 5x cubed minus 10 cosine 3x plus 2 cosine 8x. It's a crazy question, you would think, but the answer turned out to be rather simple. Okay? Now, in order to solve this, you need the following orthogonality relations. Okay? So first thing is, if you have integration of cosine n pi x sine n pi x multiplied together, n pi x, they don't have to be the same. What's this integral? Don't know? Be 0. Yes. Why is that? This is even. That's odd. Odd times even is odd. So you get 0. Now the tricky part is, how would you get the integral of cosine n pi x times cosine n pi x? What's the integral of this? And this is the thing that I explained through that slide when we first did the Fourier series. The slide in there, I explained that when n and m are different, what do you get? You get 0. N and m are different, you get 0. If n and m are equal, what do you get? Pi. You get pi. And we call this orthogonality relations. Okay? And same thing for sine times sine. See, for these, you can't use the even-odd argument because cosine is even and cosine is even. Even times even is even. So you don't know whether it's going to give you 0 or not just by having this. Okay? And it turns out that if these two integers are different, you get 0. And if they are the same, then you get a non-zero value, which is pi. Same thing here. Sine n pi x times sine n pi x dx will give you 0 if n and m are different, and it will give you pi if n and m are the same. Okay, so equipped with this orthogonality relations, now we can tackle this question. Let's multiply them. And let's see what we get. We get integral of negative pi over pi to pi, and then 4 cosine 3x times 3 sine x dx plus negative pi to pi of 4 cosine 3x times 4x dx plus negative pi to pi of 4 cosine 3x times 5x cubed dx plus negative pi to pi of 4 cosine 3x times negative 10 cosine 3x dx plus negative pi to pi of 4 cosine 3x times 2 cosine 8x dx. And see, most of these are 0. First, what's this?
0.
0. It's this case, right? It's even times odd, so it's 0. 0. What about this? Cosine is even. 4x is odd. So
0.
yeah, even times odd is odd. So integrating odd is 0. How about this? Even. This is odd powered, right? X2 odd powered is an odd function. So this overall is an odd function integrated. Will give you 0. Only because this interval is a symmetric domain. Okay. Right. How about this? Even. We don't know. Okay. We can't do this. Okay. How about this one? Even. We don't know. However, see this 3 and that 8? They're different, right? So what does the orthogonality relation tell us?
0.
It must be 0 if n and m are different. So that's 0. So the only thing that's non-zero is this thing. So let's continue to calculate. What are we getting? So 4 times negative 10 is negative 40, which should be pulled outside. And you're integrating from negative pi to pi of cosine 3x times cosine 3x. Okay? What's that? Pi. It says over there, right? The integral is pi. Therefore, negative 40 times pi. Negative 40 pi is your final answer. Okay? Now let me add a little bit more explanation to the following thing. Okay? This is a rather convoluted way of viewing this, but let me try to explain this business a little bit. This one and this one. Okay. So here's the convoluted way of thinking of it. If you think about cosine 3x and write it as a Fourier series, remember the Fourier series a0 over 2 plus sigma, and let's say L is pi, so that you get cosine n pi, so an cosine nx plus bn sine nx. I'm doing L equal to pi because the integral is from negative L to L, and L is pi. Okay. I want to talk about that result. Okay. So that's the basic Fourier series from n equals to 1 through infinity, right? Yeah. Okay. But this is already a Fourier series, don't you think? It's a trig function. So and then even furthermore, this is which one? A of what? For what n is this thing? A3. A3, right? So if you represent this like that, that means A0 is 0, A1 is 0, A2 is 0, A3 is 1, right? Because this is 1 times cosine 3x, right? And then A4 is 0, and afterwards everything is 0, okay? All right, how about B1? This is only cosine. There shouldn't be any sine. So B1 is 0, B2 is 0, everything is 0. Okay? Okay? All right. Now, think about the following. How do you find A sub, which one? 8. A sub 8. Let's think about A sub 8. The formula is 1 over L, which is 1 over pi, negative L to L, f of x, which this is our f of x, okay? Cosine 3x times cosine, because this is 8, we have to put 8x dx, right? Okay? That's what we have, right? Just using, I'm just using this formula. An is 1 over L, negative L to L, cosine, f of x times cosine n pi over Lx, right? Our L is pi, so pi cancels, so it's cosine nx, and I took n to be 8, so that's 8. Right? So that's the formula. But what do you know about the value of A8?
0.
It's 0, we agreed, right? Only A3 is 1, right? So A8 being 0, what do we know about the integral of cosine 3x and cosine 8x multiplied together and integrated over negative pi to pi? Zero. Okay. So the Fourier series actually tells us that. Okay, so it's a convoluted way of saying it because actually this is a result obtained by what I erased. So it's like taking it's like taking chicken and egg and flipping flipping it around. Is that right way to say it? Okay, so it was the orthogonality that gave us this, but we're using what we're given to get the previous result. Okay, what about A3? A3 is 1 over pi cosine of 3x multiplied to cosine of 3x dx, right? From negative pi to pi. What's A3 again? 1. So what's this integral? It must be pi. Pi over pi should give you 1, right? Yeah. So that's how you can explain that this should be pi and this should be 0. Okay? So, it's a little convoluted argument, but if you only remember the Fourier series, I'm saying that this is something you can obtain from it.